Hi, thanks for joining me. All right, teacher Jerry here. Today we are going to look at reactivity series. All right, so we earlier on we learned in periodic table about the characteristic of matter, right? We know they like to lose. So the more reactive the matter, the easier to lose electrons. Right, so there are these three reactions. And normally by now, you look at it, the big picture is that reactivity will link to displacement reaction, like what we learned in group 17. Right, so you can see that all these reactions here, matter plus water or matter plus acid. Right, remember, if you remember group 17, it's about the element. So in this case, matter is the element that we want to kick out the hydrogen. And it can only kick out if it is more reactive. That's why you get hydrogen gas. Right, so you can see the more reactive matter displays the hydrogen, right, from the water or the acid to get hydrogen gas. All right, and of course, the more reactive the matter, there'll be more gas bubbles, means faster reaction, and it will be more explosive because hydrogen is actually a flammable gas. The when we do experiment to test for hydrogen gas, the pop sound, extinguish with pop sound, is actually a mini explosion between the hydrogen gas and the oxygen in the air. Okay, so the difference between cold water, take note, is it will give you hydroxide. That's what we can relate to the group 1 alkaline metal, and steam is mainly metal oxide. So basically, steam and water, the difference, the energy, right? Steam has more energy, cold water has lower energy. So metal, you realize that cold water, right? If you look at here, only the group 1 metal, right? Mainly the group 1 metal or maybe even calcium will react. When you go to magnesium, it will not react already. So only very reactive metal will react with cold water. Right? And if the metal can react with cold water, then the reaction with steam and acid will definitely even be more vigorous. That's why they're not tested. We don't put them in steam or acid because they can react quite vigorous and explosively with cold water already. Okay, so see the pattern. Okay, don't need to exactly memorize like what explosive, vigorous, no need. But see how we use the word to relatively to show the relative reactivity. Right, even across you can see now, no, it readily in cold water, then it become more vigorous with steam and then very vigorous with acid. Right, because acid has the most energy as compared to steam and cold water. So we need to know reactivity series. Okay, there's a few of them here. Then okay, do take note. Aluminium is reactive. So by right, we shouldn't use reactive matter for food packaging, but we do use it for barbecuing some more under heat. So why? Okay, because there's a layer of they are so reactive that they will form a layer oxide. So this layer oxide makes them unreactive. Right. So technically, we normally when we do experiment, right, we may want to sandpaper to remove the layer oxide first. Next time you see you when use magnesium in your practical, check. Actually, the magnesium by right should be a shiny in appearance, but somehow it become dull because same thing. Similarly, magnesium also can react with oxygen in the air to form magnesium oxides, right? Which makes the appearance dull. So one way to memorize, that I will teach my students is that they say that please stop calling me a cute zebra. I love hairy crab so good. Right, so you can see that all these metals are below hydrogen, so that's why they don't react with hydrogen. I mean, they don't react with water, they don't react with acid because they cannot displace hydrogen from the water, from the acid. All right, so when it comes to memorizing, is really it doesn't need to make sense to people. It just need to make sense to you. It sticks with you, and then you can memorize and recall, and that's good. And you can see in this column there's this extraction. Why extraction? Because we need to understand is that all right, metals come to us in the form of metal oxides. Right? When we do mining, most likely the metals will react with oxygen in the air to form metal oxides. Right? Mainly metal oxides. Of course, there can be metal chlorides, metal sulfides, depending on what are the elements that is in the minerals. Right? But how do we get metal oxide to get metal? Right? It's actually what we call extraction. Okay, that means after you do mining, we still need to do some reactions to get back the pure metal. Now, there are basically two methods reduced by carbon. So let's understand this first. If I got a metal oxide and I can reduce by carbon, same thing. Think in terms of displacement reaction, right? The carbon, all right, is the element, then want to displace. Now, you can see now carbon is more reactive than zinc, right? If this metal is zinc, it can displace. Then you will get your zinc. in your carbon monoxide. So in this place, you get back the metal. Right? But if it's calcium, you want to displace, then cannot. Because carbon is less reactive than calcium. It cannot displace the calcium. That's why here we got no choice. Then we do electrolysis. Electrolysis, for the pure chem students, by now you have learned about the electrochemistry. Okay, for combined, just take note that it is a decomposition reaction using electricity. That's all. Right? And definitely used for metal that is more reactive than carbon. So by right, so take note of this, reduced by carbon. You see, here got no reaction. When we say got no reaction, means calcium is more reactive than carbon. Right here got reaction. That means zinc is less reactive than carbon. Right. So sometimes we like to have this tendency to see that it got reaction or faster reaction means it's reactive. Now that depends. All right. Unless we're talking about the metal itself, the metals into reaction, of course, the more reactive, the the more gas produced, the more gas bubble means more reactive. But if you're talking about the compound of the metal, in this case, the compound of the metal, like calcium oxide or zinc oxide, then the opposite will be true. So you have to be careful in this area. So that will be the extraction, again for the electrolysis, and then reduced by carbon. And actually, you can see gold is really unreactive. So last time when people mine for gold, or even now you happen to find some gold ore, what you really get is pure gold. You don't even need to go through mining. All right, you don't even need to go through any chemical method to extract it. All right, and that's why gold, one of the reason that why it's so uh valuable, because it's unreactive. Imagine it's reactive, then you very fast it will change its nature, you will change the look, then it won't be attractive anymore. All right, so do take note is that electrolysis actually can extract all metals, right? But of course, okay, it will not be cheap, because we're talking about getting metal for industrial purposes. All right, not like for lab lah, 2 kg, 3 kg. No, it's for we're talking about tons, and we need to generate a lot of electricity if we do electrolysis. So that's why those as reactive, less reactive than carbon, we can reduce by carbon. All right, if really cannot, then we do electrolysis. All right, so that will be the first part of the reactivity series. Stay tuned to the second part.